Hi, welcome to the first tutorial from Unit 2, Global Climate Vulnerability and Resilience. This relates to the syllabus, the atmospheric system, including the natural greenhouse effect and energy balance. So the first thing we want to think about in terms of the atmosphere as a system is that it's an open system. That means there are inputs into that system, there are storages within the system, and there are outputs. So immediately what we can see in this diagram are it's the main input into the atmospheric system, which is incoming solar radiation, insolation. This comes in the form of shortwave radiation, ultraviolet radiation, and it's emitted by the sun. So the main central arrow here shows the percentage of energy which reaches the Earth's surface and is absorbed by the surface. You can see that 23% is absorbed by the atmosphere and 29% is reflected. And that 29% comes from both reflection within the atmosphere, clouds, vapor, etc., but also a small percentage is reflected from the Earth's surface. So in this diagram, again, we see that 48% absorbed by the Earth's surface, and that's re-radiated back into the atmosphere as long-wave radiation or infrared radiation. And you can see it's got three elements: evaporation, convection, and net thermal radiation. Now, once the Earth's surface has re-emitted that energy, the vast majority of it is lost. So you can see we've got 59% lost here through thermal radiation from the atmosphere. And that is made up of the 25% evaporation, the 5% convection, plus that 29% reflection from the atmosphere and the Earth's surface we saw earlier on. And another 12% of energy is lost through thermal radiation directly through the atmosphere, with this 5% feedback here returned and absorbed by the atmosphere. So then what we see is if we combine all of these fluxes of energy, these inputs, storages, and outputs, we get quite a complicated picture. And actually the data you see here in this graphic varies slightly depending on the source that you're looking at. But what we're really looking at here is the fluxes of energy into the system. Here we see the absorption at 48% again, and we see reflection from the Earth's surface, 6%, 23%, reflection from the atmosphere, adding to this 29%. Again, we have convection and evaporation. And we've got surface radiation. What's interesting here is this 117%. How can that be above 100%? Well, remember we have the role of greenhouse gases here, which trap energy, trap long-wave energy, and return it back to the surface. So this has a sum total of 117 because it's combining with that back radiation of heat trapped by greenhouse gases. So finally, just looking at the greenhouse effect, something I think you'll be quite familiar with, but greenhouse gases such as methane and carbon dioxide are in abundance in the atmosphere, and they trap that long wave radiation and return it back to the Earth's surface. So in total, the natural greenhouse effect keeps the atmosphere at approximately 15 degrees Celsius warmer than it should be. And without it, our planet would be a frigid planet. It would be just too cold for life.